Okay, overall, the this test, the fourth one, was actually answered very well. So let's sort of go over the kind of the finer points of some of the issues. Drawing out a chair structure, most of you seem to be getting that done very well. Remember that the opposite lines must all be parallel to one another when we're doing that. And really, for both conformers, it's possibly actually just the easiest thing is just to draw out exactly the same chair structure and then just put the substituents on in a different position. So just get the structures out there. Okay, so we've got both ones. One looks a bit neater than the other one. And now let's go around clockwise. I'm going to put the bromine on. Let's put it at this position over here. Up at this position is like that. It's in an axial position. Down next door, straight down OH. And then we move one across, and then the isopropyl group is straight down. Okay, notice I'm not doing wedges or dashed bonds, just straight line. So we want to draw the other conformation. All we do is we just start one atom across from where we did this one, or we just move around one. So at this position here, or at this position over here, we would start putting the bromine. I'm going to put it here. And it's now the up position is equatorial. It's parallel to that line there. So we've got the bromine. The OH is over here, and it's parallel to this line. Okay, and then we go to the isopropyl group, which is parallel to these two lines, and it's like that. Okay, and this, of course, is the preferred one because everything is in an equatorial position. Okay, you may have drawn these slightly differently, so long as you follow the rules, and you will see by your marks whether you got that right or wrong. For the two conformations with epoxide, so we draw our cyclohexane half chair, but the epoxide is facing down, so I'm just going to put that down there now. And the one conformation will look like that, and the other one, let's put the epoxide facing down, go boom, boom, the other one up, and it'll be something like that. And notice these bonds come in at an angle here. They're not going straight down and then across. All right, there's an angle of about 30 degrees or something there. Okay, so those are the two. Note the epoxide is on the lower face. It's down. It's not on the upper face. A lot of you had did. And then the isopropyl group is down on this carbon, so we're going across 1, 2, 3, 4. We stuck our eye here. So looking at the eye, looking across here, 1, 2, that's 1, 2. 1 to the left, 2, 3, 4. And the isopropyl group is down. At that position, must be straight down. It's axial. And over here, that's the same position, 1, 2, 3, 4, and down will now be equatorial. See, I've drawn it going slightly down. It's not straight across in line with this going slightly down. And this one will be preferred because it's in the equatorial position like that. All right, so that's 6 marks. Okay, difference between conformation and configuration. Conformation is different 3D shape owing to or because of free rotation around sigma bonds. Or single bonds, you could have written that as well. For example, your chair and a boat conformations. Okay, so that's a good representation of this one over here. Some people said that cis and trans. Cis and trans are not conformations, they're actually configurations, because configuration is also effectively different 3D shape. But the real thing is because of 3D it's because of stereochemistry, which is good because stereochemistry is more encompassing than just R and S chiral centers. It's because of stereochemistry, because that could be diastereomers as well. So different 3D shape, stereochemistry can only change through bonds breaking. And of course, then many others, right? E.g., your R, S, and also cis, trans would have been good for that. Okay, that would have been 3 marks for that. And then lastly, just drawing out the IUPAC name with the correct chiral center on it. So a cyclopentanone would look like that. So that's our cyclopentanone. And then we want a bromine and a tertiary butyl group on in those 2 positions. So that's those over there. Sketch them in quite lightly. And so then we have to decide the bromine is on the 2 position and it needs to be R. So bromine gets 1, this position over here is 2, and that's going to be number 3 because carbon is the same. Carbon goes to oxygen, wins over carbon, going to carbon. 1, 2, 3. So going round to the left, okay, 1, 2, 3 would give us an S, but in order to, because it is going around to the left, in order to get it R, we have to look at it back to front. So we put the bromine going towards the back, and that H is pointing forward. And we can work this out for the T-butyl group in exactly the same way and work out that actually it needs to face up. So 1, all right, this carbon wins. Carbon, 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 no difference. Carbon goes to oxygen, wins over carbon is going to carbon. So 1, 2, because this one goes to more carbons than this one. 2, 3. So we're going round to the left, which is S. It's pointing up, hydrogen is the back. It's supposed to be S, so we've won, and that's it. All right, so that was the worked answers for weekly test number 4.